So this is the next example I'm going to go through, so I recommend pausing the video and writing it down. So we know that f of x is equal to x to the power of 5 take 60 x cubed. So it says find the value of x at each stationary point. So that's our first step. Well, at stationary point we know that our differential is equal to 0, our first differential. So we need to find f prime first, which is our differential. So we get 5x to the power of 4 take away 180 x squared. So we want to set our differentials equal to 0, which means that 5x to the power of 4 take 180 x squared equals 0. We can factorise this, so take 5x squared out, we get x squared, take 5 into 180 is 36 equals 0. So we end up with 5x squared, we've got difference of two squares here, x plus 6, x subtract 6 equals 0. So we know that x is equal to 0, we know that x is equal to minus 6, and x is equal to positive 6. Okay, so we now know that we've got three stationary points, one when x is 0, one when x is negative 6, and one when x is positive 6. We need to determine the nature of each one. So to determine the nature, we need to use the second derivative. So we need to find our f double prime, which is 5 times the 4, 20x cubed, take away 180 times 2, 360 x. When we take 1 from the power, it's just 1, so we leave it like that. Okay, and we need to find the value of this second differential for each of 0, negative 6 and 6. So we've got f prime of 0, so we've got 20 times 0 cubed is 0, take away 360 times 0, which is equal to 0. Okay, so this could be, remember when our second differential is equal to 0, it could be a minimum, a maximum, or a point of inflection. So we need to do some further we need to look at this point a little bit further. F prime of 6, 20 lots of 6 cubed, take away 360 times 6 is equal to 2160. Okay, this is greater than 0. So to distinguish between maximum, minimum or point of inflection, we know it's not a point of inflection because that doesn't equal 0. It's greater than 0, so we know it's a minimum. Okay, and then final one, negative 6. So at negative 6 is negative 2160, which is less than 0, so hence it's a maximum. Okay, so we found our three stationary points and we've kind of established that at 6 is a minimum and at negative 6 is a maximum, but we still haven't sorted out what happens when x is equal to 0. So we need to look at kind of values very close to x equals 0 to see if there's a change in sign for the second derivative. So close to x equals 0, so we'll do negative 0.1. So when x is equal to negative 0.1, we've got 20 times negative 0.1 all cubed. So remember I'm using my second derivative. Take away 360 times negative 0.1. So that's 35.98, and then we know that that is greater than 0, and then we're going to do it at normal, so positive 0.1, is negative 35.98, which is less than 0. So when it's less than 0, we've got concave, greater than 0 is convex. So there's been a change in sign of the second derivative, so we know there's definitely a point of inflection. So we're going to just write out a kind of final statement. So when x equals 0, there is a point of inflection. When x equals 6, there is a minimum. When x equals negative 6, there is a maximum.